and you learned that physical properties are properties that can be observed without changing the substance of the item or the identity of the substance, right? So we could take a look at this piece of paper and make some observations about the piece of paper without changing its identity. So I can describe its color, it's white. I can describe its flexibility. So it's pretty flexible, right? I could bend this and shape this into some different ways um, and say that it's pretty flexible. We also know that it has a density. Its density is light. We could figure that out by doing mathematical equation, mass divided by volume, and then we would figure out its density. All right, so those are some physical properties used to describe this piece of paper. A chemical property would be a property that I would observe that would change this piece of paper into something new. So I could light it on fire, right? Flammability. So if I observed flammability, and if it was flammable, then we would see it turning into some different substances. And also reactivity. So if I put it in a substance where it reacted with something else, then we know it has that property of reactivity. So I'm going to take a pair of scissors and I'm just going to cut this piece of paper. Okay. And I changed it, right? So now we're going to kind of get into physical and chemical changes with this piece of paper. And I've changed it in one way. I've changed its shape. I've actually changed its volume and its mass. So now I have two separate pieces of paper with different volumes and different masses than the original, right? So I've changed it in some way, but I haven't changed the identity of it. It's still a piece of paper, or now two pieces of paper, but it's still paper. If we were to figure out the density of each of these pieces, this piece would have the same density as this piece, and they would have the same density as the entire piece of paper. So we haven't changed the density of the paper. Yes, we've changed its volume and mass, but mathematically, if we were to work it all out, the density of each of these pieces would be the same because they're both pieces of paper, the same piece of paper, just now in two different pieces. Okay, so that's a physical change, just cutting it. What's a chemical change? Well, let's do a chemical change on this piece of paper. So I'm going to take this lighter and let's see, get it going. There we go. Now I'm going to burn it. So we'll apply the flame. And already we can see, get my goggles down. We can see that there is a physical change happening. There's a color change. There's heat. So if you can imagine, there's some heat there. And I don't know if you can see it, but there's some smoke coming off of this. And then I can even see little pieces of paper dropping, and it's now ash. All right, so I'm going to put this down, and I'm going to show you one thing. I hope you can see it. There's some water on that table. I don't know if you can see that water there off to the left of the paper, and then you can also see the ash. But we have now taken this paper and we've turned it into completely different substances. I can still see the smoke, so that's carbon dioxide, and the ashes, and even the water on the table. So there's water in the paper. And when I burned it, the water was released out of the paper. Whew, smoke. Man, I hope the alarms don't go off. That'd be pretty crazy, right? All right, so that's a chemical change that I made on the paper just by burning it. And there's evidence that there was a chemical change. Brand new substances. It's not paper anymore. Okay? All right. So now, a couple other things that I want to just show you, going back to physical and chemical properties, are these two, or actually two different kinds of cubes. Actually, I've got a lot of different kinds of cubes, but two different like color variations. But I have 5 cubes here. They're all the same size, and they all have the same volume. So when I say same size, I mean same volume. Okay, so they take up the same amount of space. And I've got, let's take a look at these two. These kind of have a gold color, right? So that is a physical property, color. And right away, I can just eliminate the type of metal it is. I know then it's not iron, it's not nickel, it's not can even be steel. It's got more of a copper or gold color, so maybe it's copper, maybe it's bronze. Those are more of the color that copper and bronze would be, just kind of this gold color. Then I have these three that are kind of more silver or gray, and maybe one of them's iron, maybe one of them is nickel, one of them could be steel or even aluminum. So right away I know that these aren't copper or gold just by their color. They also have different densities. This one's pretty light, so this has a different density than, let's say, this one, which is a little bit heavier. Okay, even though they have similar volume, their masses are different, which is going to make them have different densities. So when we figure out their densities, then we can identify exactly what metal it is, because each metal or each type of metal has a specific density. So that's a physical property, density, that helps us figure out, what metal it is. Okay. Another physical property we can use to describe substances or identify substances is a magnet. Okay. And we know that iron is magnetic. Steel is magnetic because it has iron in it. Nickel, I think, is magnetic, but aluminum is not. Most metals are not magnetic. So if we can identify through magnetism, then we actually just eliminate a lot of metals right there based on magnetism. So this magnetic, nope. This one magnetic, nope. How about this one? Nope. How about this one? Yep, so that one's magnetic. So this could be, iron, it could be steel, it could be nickel, just based on magnetism. But other things that we would do to figure out what this actually is would be figure out its density. So we know it's magnetic. If we know its density, then we know what metal this is. Okay, so physical properties help us determine what a substance is. Okay, all right. So let's talk more about some physical or chemical changes. Okay, so chemical changes are any changes that we make on a substance or matter, and it changes its identity. So I'm going to show you a few different examples of that. First of all, I've got a little beaker here with about 150 milliliters of water. Okay, and then I have some Alka-Seltzer tablets. All right, pretty common item. You know what those are. And I'm going to place them into this water, and we're going to see a couple things. You notice that it's forming some bubbles, so it's fizzing, and the bubbles indicate that a gas is being formed from the Alka-Seltzer in the water. Okay, so that's a chemical change. I'm going to add this bromothymol blue, which is an indicator. And when we add the bromothymol blue, now we see this color change. And it's pretty evident there that this is a chemical change because of the change of color. We've got some bubbles, and I no longer have water and Alka-Seltzer tablets. I actually have totally, completely different substances. And this would be something you would not be able to drink, okay? Because they're completely new substances, all right? So that's a chemical change. Bubbles, color change, tell us right away, right there, chemical change. All right, I have here this plate that I'm going to pour this chemical in. Okay, and I've got a little bit of and I'm going to show this a little bit down. I hope you can see this. This little piece of styrofoam from a plate, and I'm going to place it into the chemical. And I don't know if you can see that. I'm going to pull it out in about 30 seconds to a minute. And we can see that it's already changing its identity, because when I pick it up, it's not going to be this hard, brittle substance that it was. This chemical that I put it in has changed its properties. Now it has different physical properties. It has a little bit more flexibility. It's stretchier. It is not brittle and hard anymore. So that's an indication that a chemical change has occurred there. Okay. All right. This one, here we have some yeast. I had to go to like 3 different stores to find yeast. Everybody's making bread right now. And it's really hard to find yeast. I don't make bread, I buy bread, but everybody's making bread right now. So I'm gonna take this yeast and I've got some hydrogen peroxide, about 30 milliliters. I'm gonna place it into this bag. Oh, it already spilled. It's fine. Close it up. We'll mix them together. Now, if this works, this will be a little interesting. If it's good hydrogen peroxide, if it's not old hydrogen peroxide, then we should get some results here. There we go. So that is some gas forming. So we've got some bubbles coming out of our mixture here, or our reaction here. And you can't feel this, but it's warm. So this is what we consider an exothermic reaction because energy is being released and we can feel the heat. Okay, it's quite warm where the bubbles are. And then we can see that the bag's even getting a little puffy because of the gas that's being formed from the hydrogen and peroxide and yeast combining and creating this reaction. So, okay, so that's a chemical change. Totally different substances. I can't turn that back into hydrogen peroxide and yeast. New substances, gas being released. It's, in the bag, but it's a new substance that wasn't there before. All right, these 2 flasks. One has water, one has vinegar. I don't know which one's which because I didn't label them. But I can figure out which one had vinegar and which one had water because I have baking soda in these little balloons. And when I pour the baking soda into the liquid and they combine, we're going to see a reaction with the vinegar and the baking soda. And I don't think we'll see a reaction with the water. I mean, you guys have done this before, so you know what happens. So let's see what we got here. Here we go. So the one, it's gonna pop. The one on the left is the baking soda in vinegar. So we see the gas collecting in the balloon right there. We see the bubbles going up there into the balloon. It's kind of cool. All right. And then this one was just water. Okay. And we don't really see any bubbles there. We just see a mixture of baking soda and water and no reaction. So Mr. Gaylor is going to come on next week and talk to you guys about mixtures. But when baking soda dissolves into water like this is a physical change, not a chemical change, because no new substances are being formed here. It's just, they're just together, basically in the flask, the baking soda and the water. So a mixture is considered a physical change, okay? All right, I think that's it. So hopefully you have a better understanding of what physical properties are and what chemical properties are, what physical changes are. So just cutting paper is a physical change, but when we burn the paper and we create something new, that's a chemical change. I can't reverse this action. I can't replace this paper and turn it back into paper because it's now ash, water, and carbon dioxide gas. So that's a chemical change. All right, in this lesson, you've got the video that you just watched, and you also have a couple videos, physical change and chemical change for more information. So you could view those. You also have a link on the Google Classroom to the online text. Make sure you open that text and use the textbook information to help you with the document. So the document goes with the text, and there are page numbers in each of the questions, so you know exactly what page to go to get the information, okay? So hopefully that helps. And check out Google Meets with your teachers and their office hours and join those office hours if you have questions. You can also email your teachers or get them on Hangouts if you have any questions. Other than that, you guys have a great day. Stay safe, be kind to each other. All right. See you later. All right. Figuring out how to stop this.